Hello and welcome to episode 44 of Cooking with Unity. I'm your host, Max Moreau, and with me is my tech, Philip Wilson.
Hello, 44.
So, on the last episode, we were working on a little pinball game. So I've got the project here opened up, and we've got what we started on so far. So what we have working right now is a few little bumper things that just apply force to the ball. And I think the ball will eventually just launch out like there. All right, there we go. And we had this problem. We have the flippers working. They're on one button right now, but they weren't actually working. Like if we move this ball into a position so that it will contact one of the flippers, you'll see that we don't really impart any motion to the ball, even when we kind of crank the values here. And so I was playing around with this, and I've come up with a different solution to the problem that appears to fix our problem. I think it had to do with the fact that we're using transform.rotate or rotate towards, and that doesn't really give the physics system a lot to work with. So we're going to switch it to a more physical simulation here. So what we're going to do first is I'm going to keep our flippers the way they are, and we're just going to work on a new flipper. So we're going to create a capsule, and we're going to set this one up a little bit different this time. So we're going to stretch it out the same amount so that it looks about the same. So this one's 1.5 in the Y, so 1.5, and then we're going to rotate it. I'm just going to use the tool this time, and we're going to rotate it along until it gets to, well, we'll just do 90. That'll be good. And then what we're going to do is we're going to attach a physics hinge joint to this thing.
Oh.
And by default, this actually has things set up pretty nicely. We're gonna move it slightly because we want it to kind of pivot on this portion of the axis. I guess right when it turns into the
Right
sphere.
where the circle turns into the sphere.
Yeah. So basically, the default settings here, we have the anchor here, which I guess normally this is 1. I don't know why that was close to 1 before, but whatever. So this is the offset. So if we set this to like 0.5, you'll see it comes up a little bit from it. This is assuming that the orientation had not been changed. So like if we were at 0, this makes a whole lot of sense. The Y, if we do 0, 0, 0, it's right in the middle. This is the direction that it can rotate around. This is the axis of rotation. And so that can point really, like, this could be 1 or -1, and it'll just change the sign that you need to bring in for the rotation. But otherwise, that's exactly the same. If you wanted to rotate on a non-standard axis, you could do that. So like that's kind of 1 into one axis, 1 into another. What we want is actually what it was defaulting to. So we just had 1 on the x-axis, which brings it outwards, and then we want to have the anchor point be a little bit less than 1. Let's do 0.75 will probably be appropriate. Not 75, 0.75. Maybe a little bit less. Let's try that. Let's try that first. So, 0.7, whatever. I never decide things, do I?
It's okay.
0.6. 6.5. There, that looks good to me. All right, so let's rotate this back to 90, and let's just hit play and see what it does. So, oh wait, we don't have it close enough to anywhere we can see. So let me just move the Y position down a bit. We'll hit play. You'll see that it flops down, and that's because our gravity is pointed slightly towards the screen. Remember, we decided to switch the gravity so that we can keep everything flat on the table, and then we can just adjust the gravity vector at any point. So this is a hinge. It just will swing on that hinge forever, probably.
Until it stops.
Until it stops from air friction, which I'm not even sure if the default settings will allow that to happen.
It looks like it is slowly.
Maybe. It looks like it's kind of maintaining a momentum here, but maybe... No, maybe it's losing some. Yeah, it's losing a small amount each time. So what we want to do is we actually want to limit its movement, which is quite easy. You can go into the limit section. You click Use Limits, and this is the degrees and angle, the angle in degrees. So I'm just going to do -25 and 25, and we should see that it will now hang down to about where we wanted it. And so we have the basic version of a flipper there. So now all we need to do is actually apply a force to it to kick the flipper out. Probably the most appropriate way to do it is not immediately easy to do. The most appropriate way would be probably to apply a torque to the point. Built into Unity, there is no apply torque at position, so I ended up using apply force at position and pushing it from the outer edge. So that's what we're going to do here. You can probably get the other to work. As a matter of fact, I found a general theory on how to create a torque at position that basically does a calculation to apply a force at the opposing position or something. So basically it applies the force in a way that is consistent based on a certain distance from the rotation point.
That's cool.
But we're not doing that.
So applying force like this will allow it to interact with the ball properly.
Exactly. So we're going to call this one apply force on at position. I'm going to say at offset. Apply force at offset on button. We'll just do apply force at offset, whatever. It's descriptive enough, and that's the bumper. That's not what we wanted. So what we're going to do on this one is it's going to be pretty basic. Public float force. Public vector 3 offset. And public vector 3 direction. Let's not use that. We're just going to make some assumptions here. So what's going to happen is we're going to do a rigid body. Okay, so if input dot get button. Okay, we're going to want to apply this here, so we're going to need a public string button name. We're going to default that to fire1 because that one's built in.
Yep.
So button name, and we're going to just be using get button on this because we actually want it to apply force forward when the button's down, and we want it to actually apply the force backwards when it's off. We're doing that as a simple method. Gravity is not what pinball machines rely on for the flipper coming back. The flipper is actually controlled by a solenoid and a spring system. And so the solenoid pushes the flipper out, and then when it retracts, the flipper actually flips back into position from spring force. Mm-hmm. We're going to basically be simulating kind of the same thing, except for we're going to be applying the force to the end of the flipper, and we're going to be pushing it up during the whole time that you hold the button down, and then we're going to be pushing it back the same amount when you're not holding the button down. And it should basically, in principle, work the same way. You could have two force values if you wanted to get it really tweaked in to feel like a real pinball machine, but we're not going to worry about that. So if the button's down, we're going to rigid body dot add force at position, and the force will be we're going to do the force direction as transform dot hold on, which direction are we pushing? We're going forward, I think, but let's double check. So
would it be a Z?
We are going to want to be able to set the
value.
Let's just actually make it set. So we're going to do public float force direction, and that's not supposed to be a float at all. That's supposed to be a vector 3. So we'll do force direction dot normalize times force, and the position will be transform dot position, because this expects a world position, not a relative position. So we need to add its own position and add the offset to that, which will give us the position in space that we want to apply that force. And let's set the force direction to be equal to vector 3 dot forward. So that should be into the z direction. We're going to see how this actually works. So, and we're going to set the default force. I'm going to go for 100. And so that's half of it, and then the other half of it is returning back. So we just do else, and we do the exact same thing, except for we do times negative force. So let's see what this does. So if we hit play, it doesn't do anything because we didn't attach the script. So we attach the script to our capsule. I'm going to rename this to Better Flipper. And now it's working. So we can see that these don't really work well. So let's get rid of the left one here and replace it with our newfangled contraption. So I'm going to, so 12.5, so negative 12.5, 0.5, and what position is this in? Negative 2.75. So negative 2.75. And let's make it.
But it was offset a little bit.
2 is good enough.
Yeah.
There we go. So let's get rid of the left flipper and just delete it. And that was duplicate. Let's try that again. Left flipper, delete. There we go. So here it comes. It's coming down, and we hit it with the flipper, and it actually gets some upward momentum there. So let's change the force around a little bit more. Let's get to 250.
Oh, I would have gone to 1,000. It's because I like seeing things
250.
shoot out of levels.
All right, you want to see it shoot out of a level? Yeah. All right, let's do 1,000.
Makes my life worth living. Well, that's about right.
It gets a little twitchy because it's pushing it back so hard that the physics system is not sure how to constrain it properly. But it's not too bad. So we're going to do 250 again, though, and I'll show you why in a second here. We also didn't actually apply our offset, so we're not getting the full effect of our force here. So I'm going to actually make the offset here. So right now it's just applying it to the center of it, which will still work because you're pushing there. But as you know, fulcrums apply force
Yes.
based on the distance from the joint. So if we actually offset this to
What is it?
let's
X1?
do, yeah, it'll be y negative 0.5 or something. Let's do that. This should get a little bit more kick. I'm not even sure if it is getting more kick or less kick. Let's try negative 100 and see if we get something crazy. Doesn't really make that big of a difference, does it?
Is it along the Y?
Maybe it's not. Would have thought it was, because this is the Y direction for the object itself, although, yeah, no, that's not how it works at all. So, actually, yeah, we want this along the X. Let's see what this does.
Negative 100's behind
Okay,
it.
so that's causing some problems. Good. There we go. That's more like it.
Yeah. Look at that.
All right. That'll work for right now. So, we've got we've got some work to make this feel like a real pinball machine. One of the things that I like to note in a real pinball machine is if you have a ball with a certain amount of momentum, it should bounce cleanly to the other paddle.
Yeah.
So we're going to try this a little bit here. And it's not going to at this case because we don't have the settings nice yet. So one of the things that we're going to probably want to change is the bounciness stuff. And this is not immediately obvious how to do, and so hopefully this will actually help some people out here. So what we're going to want is a physics material. And this allows you to tell what materials do when they touch each other. So we're going to call this I'm going to call this main material, and we're going to make something that's just going to apply to all the objects by default. And I would like to start this way because it kind of gives you a conceptual of what you want, how you want things to act in the general case, and then you can modify things later from that general case if you need special cases. Like generally, you want the ball to bounce off of flippers and bumpers and objects, but you don't want it to bounce too hard off the table so that it doesn't fly off into the air and into space and stuff. So you might make the table more absorbent, or you might not. I mean, real pinball is pretty bouncy, and they just try and keep things on the ground if they can.
It's just that the ball's heavy.
Yeah, the ball's heavy, but the ball's also not as heavy as well, I don't know. Yeah, the ball can be heavy, although the mass of the ball, it works differently than you'd expect when you're playing around with a physics system. And sometimes to get things to simulate nicely in a physics system, you might have to do things that are counter to what you expect them to be.
Yeah.
Just because the assumptions that the physics system itself has built into it may not work exactly the way that the real world works. So here we have our main material. So what we're going to do first off is go into project settings, physics, and we're going to throw this into the default material. So now this material is being used at all times. And if I'm not mistaken, this is the one that you generate when you just create a new material is what the default material is it would use normally. Like it has the same properties as you would use. Maybe it's a little different because it seemed like that came in with a little bit more force than before, but maybe I'm probably just crazy. So it's bouncing a little bit better over there. So we've got this vector, this thing called bounciness, and the other thing that we have to pay attention to is in the main project's physics settings, for whatever reason, the bounce threshold is 2, which is a lot of force actually to require for a bounce. If you're making a Pong game using the physics system, you would set this to like 0. Like it would be as close to 0 as you could dare to put it. We're actually going to try 0.1 to start and see how that does for things. Let's see if we get a little bit of a bounce on the ball here. We probably won't because we still haven't made the ball very particularly bouncy. Okay, so now let's actually play with the main material here and set the bounciness. Let's do 0.5 to start to see how things go. So you should see this thing's now bouncing as it hits the ground here. And it didn't bounce that much. You're still kind of getting some force absorbed by the actual paddle because the paddle, even though we have it hinged and we have a constraint, the constraint's not a 100% forced constraint.
Yeah.
And they do that because it looks more realistic if it's not that way. There's almost always some give on any material that you're working with. But we can't really adjust that, so we have to just keep that in mind. So let's try changing some of the values here. Let's go to our sphere here. We're going to actually rename this to ball. And let's try making this lighter. Let's make it 0.2 on the weight. And let's see how it does now. It still isn't that good. Let's try making it a little bouncier. Sometimes there's a little bit of trial and error when you're doing this stuff. Let's try 0.8 on the bounciness. And let's try bounce combine maximum. This will basically make it so if there's a bunch of bouncing, it takes the highest value rather than the average value between the two. Oh, now it's real bouncy over there. Okay, that's good. Oh, that's kind of more what we want, although now it's bouncing off the board too much.
Yeah.
We can simulate what it'll work a little bit better by being a little bit less cavalier about where we put the ball. So now it shouldn't bounce immediately. Although you can see it's kind of getting some bouncing stuff there. And it kind of flopped off again. Let's try it again. Let's go again. Let's just see what happens if we do one, just for the fun of it. Oh, now it really likes to bounce.
There it goes.
Yep, there it goes. But it's bouncing all over the place on the back wall.
Whoa!
Let's try going back to average here. Just see how that does. About the same. All right, so that bounciness we're getting off the table, even though it's not doing anything, we can fix that with the bounce threshold here again. We can actually set this a little bit higher. Let's try 0.5 and see what we get. Still kind of going crazy. Let's try 1.3. There we go. Now it's not bouncing down the way,
But
it also didn't bounce very much there. Oops, that didn't save. Let's try 0.8. And let's go back to maximum. Let's go back to 0.8 here. Just play with values. Just keep tweaking things. And that felt pretty good. I kind of liked that. That actually had a pretty good feel to it. All right, so let's get this better flipper. Let's create a prefab for it. Let's put it on the other side too, because we already have decided that it works better than our previous flipper attempt. So I'm just going to delete the flipper here. I'm going to leave it in there just for the sake of understanding how other ways you can set up things and how sometimes the way that you set it up can make a big difference on things. So, so let's look at rotating this -90. And let's see if that just magically works.
Position should probably be at 2.
Yeah.
Right. Kind of worked.
It's kind of weird. Oh, is it?
It probably needs to apply the negative axis.
Why is it doing that? This looks more like it's colliding somehow inside of, because the axis should be pointing down, so that should still work.
No, I'm talking about in the hinge joint.
Yeah.
Didn't you talk about the axis during that? That's at 1 currently. Wouldn't it be opposite if it was negative?
Yeah, but we want it to be opposite because. Well, let's see what we got. Oh yeah, I see what you're saying. I got what you're saying. So yeah, because it's actually where we're applying the force of this problem. The direction's fine. It's the offset that's not fine. There we go.
Yeah.
And that's because even though we kind of set it up as a relative offset, it's an absolute offset. It's not based on the object itself. We could change that. I'm not going to at this point, but the way that you would change that would be you could, if you wanted the offset to be based on the relative position on the object rather than the world offset, you would use, instead of transform dot position plus offset, you would use transform dot position plus offset. I actually don't know how you do it. There's a way to do it. I don't know why I can't think of it right now. All right, so we're just gonna leave it like this. So let's get him working on different buttons too. Let's go ahead and we're gonna call this the left flipper and the right flipper.
I think those are just reversed.
You're right, they are. So let's call this. Actually, let's call it flipper left and flipper right.
So they're next to each other.
And I still got them wrong. Left. Right. So now we can take our flipper left. We'll do fire 1. What's the default project stuff here? Let's go to input, axes. So we got fire 1, which is left control. What's fire 2? Left alt. That'll be good enough for our purposes. So I'll just do fire 2. So now we have independent flipper control, joy of joys. And yeah, those bumpers were rated for a much heavier ball and a much less bouncy ball. That I don't like that just did not bounce at all. I'm going to change the bounce threshold again. Okay, so we want it to be bouncier, but we don't want it to bounce off the table as much. So let's go back to physics.
Why don't you make the ball heavy and the flippers bouncier?
Okay. Right now we're looking at pretty high bounce already. So if we make the ball heavier, it's actually probably going to absorb more impact when it hits the flipper, unless we make the flippers heavier too. Let's try that. Let's try both those things. Put the mass at 1. And let's see what happens if we increase the mass of this. Let's do this to 5, just for fun. Yeah, that's better.
Yeah, that's much better, actually.
All right, so let's get these. So what did we do for the ball? We did 1 and 5. All right, let's.
Should put it at 4. The mass.
You think so? 4.
Yeah, a little less. It was bouncing a little bit far. Kind of wanted to have a nice little pass, and that.
Yeah.
Might even still be a little bit
3.
too high. But
Let's try 3. Or we can adjust the bounciness or something. You're going to want to play with the physics early on, and you're going to want to not be afraid to change the physics too much, but at the same time, like, anytime that you change physics, you're going to be changing it in a lot of different places.
Yep.
And so you want to try and get the basic idea of how it works down first. So what I would suggest is if you're making a pinball machine game, you start with just getting some basic stuff like we've spec'd out here, but then also try and start building your environment, start seeing how it does with your ramps and whatever you add in there, and curves, and just try and make it so that it feels right. I mean, it doesn't matter if it's real, it matters if it feels right. Like, actually, one of my favorite pinball games of all time, for software pinball games, is Intergalactic Pinball. Was that what it was called on Virtual Boy? It's a strange one to reference, but it's a good one. It had a puck. Like, they didn't even want to give the user the implication that it was a ball, so they had this little puck, and so they were able to be a little bit more fast and loose with the physics on things. And they do a lot of guiding stuff, and honestly, when you're making video pinball, you're going to cheat a little bit. If you've played even ones that are based on real pinball machines, there's like what's that set called? The Pinball HD collection? Is that what it is?
Oh,
the one that's on like everything.
Oh, what is it called? It's like just called like Pinball Arcade or something.
Yeah,
like
Pinball
that.
Arcade.
It's made by
it has a whole bunch of real pinball things, and if you actually really pay attention, you'll notice that like when you hit a ramp, it sometimes applies a little extra force to your ball. You'll notice there's places where it'll fudge a little bit here and there to make it feel like it's flowing right, even though it's not. Like, they basically had problems, and they were like, oh, okay, let's just add some little helper things here that you can't see, but they make the game work a little bit better. And so don't be afraid to cheat. Like, never be afraid to cheat, even when you're trying to make a simulation. Maybe especially when you're trying to make a simulation. So these things are still way too powerful. Let's look at our bumper and change the force on these to. Did we change them all individually? That's weird. Let's change the force to 1,000 on these and apply it so it goes to all the other bumpers. No, it doesn't, because they all had changed. So 1,000. apply. I don't know how we get it so that these. I guess I can do. Nope, reset's not right. Let's revert. There we go. We'll revert all of these. And we can't revert multiple things at a time. So it's back to clicking and pressing down. Revert. Revert. I'm not complaining because there was a time when Unity had even more stuff that you couldn't, like there was no concept of multiple selecting and changing anything, so I'm happy to have something. Just because it doesn't work in one case is not gonna make me go irate. So let's see how these bumpers do a little bit now. Still a little bit greedy on that, so let's do, now we should only have to change it one place, so if we do 500 and hit apply, it should apply to all the bumpers. Good. That I think will work.
I think we should get some sides on that table so it stops flying off the board.
So, yeah, let's do some sides. We're going to do some really ghetto sides. I actually have some art assets that Chris, my partner, set up for... I'm not sure if I'm going to use them this episode. I'm probably going to use them next episode, but he made a flipper and a few back faces and stuff so that you can see kind of how you'll work with a real thing. I'm not hesitant to use it. My only worry is, like, I don't have a video of how those pieces were created. He made them very quickly in Moment of Inspiration, which is a great program, but I don't know heads or tails through most 3D programs, so I'm not very helpful on that. Let's put some borders on the table. Let's make the table a little bit bigger too.
All right.
So we got this plane. We've got 1, 1, and 3. Let's make it wider. Thickness doesn't really matter, does it? So let's do 4 by 3 because that's a good aspect ratio, right?
It's a huge table.
Yep, that is a huge table. Let's not do that aspect ratio because that doesn't really look like a pinball table.
That does, though.
That does. That looks pretty good. Let's go ahead and move the table up a little bit. So we're going to just move this into the Z. About like that. And let's go ahead and just create some cubes to just sketch out our table area. So I'm going to move it to the edge about -9.5 seems about right. And we're going to make this, how long is the table? It's 4 long. So 4 times 10 because this is the plane.
40.
So it's 40 units. 40, that's the wrong one. We want Z40. And now we can just position this in the middle here somewhere. And let's make it actually on the table, so 0.5 I think is the appropriate amount. And let's slide this in too. So this is at 301. Let's just see 3.
All right.
Duplicate that. Put it over here at 9.5. And then we're going to create another cube. Actually name these real quick. This is right wall. Actually, wall right. I'm doing the reverse thing just so that it sorts nicer, so that the walls will be together and the flippers will be together. Wall left. Duplicate again. This time we're just going to take it down to 1 and take it down to what, 20 across? Yeah, that's about right.
I don't know.
Somewhere.
Yeah, it's
somewhere up there.
About there.
Yeah, about there. That looks pretty good.
Called
22.5. This one's going to be called wall top. Duplicate again. Going to have a very square, very old school pinball. It's going to look more like bumper ball type stuff right now.
Pachinko.
Or pachinko, yeah. So we have our basic play area.
And now the ball's doomed.
And now the ball is totally doomed. That is the nastiest drain in the world as far as as far as things go. Let's actually make it so you can lose the ball. All right, so let's make another element of a typical pinball machine. We're going quote unquote modern style pinball, even though it doesn't look like it so far. They're like this looks more like a old school like pachinko or just parlor completely mechanical pinball machine setup.
The early Gottlieb stuff.
Yeah. So we're going to start making it look like a real modern pinball machine. So we're going to need a plunger. So let's make a little plunger area on the right hand side of the board here. Let's see how far we've spaced this. So 9.5 we want. So 8.5 would be not enough. 7.5 is exactly, so we want to actually make it like 7.0. So there's a little bit of movement for the ball.
Yeah, you don't want to trap a physics object.
Yeah, let's actually do 7.25.
Okay.
Let's make it close. And we're gonna need to make this a little bit shorter. So let's make this let's make it 50. No, sorry, that's not short at all. 30.
All right.
And then just make it even to whatever. There we go.
Works for me.
And so we're gonna need some sort of plunging device. So how are we gonna approach this?
You could just have an object that when you press a button it applies force.
Yeah, we could just do a force launcher type thing. Let's do it. So we're gonna do the button style launcher, not the plunger style launcher to start with. So I'm just going to create
do that later on too.
Yeah. So first of all, I want to see what this duplicate wall. We're going to call this the plunger track, and so we've got a plunger track. Let's create a cube and call this the.
Call it the launcher.
Yeah, call it the launcher. Actually, okay, I know how we're gonna do this. We're gonna call this just the launch plunger back. Throw this somewhere in here. 5 and X position is probably 8.5. Let's see what this actually looks like when we. Wait, what did I just do?
I don't know.
Okay, I want to focus on. There we go.
Oh, okay.
So.
Yeah.
That'll be fine.
You're not gonna put it at 375.
375.
Yeah, that's what I'd put it at.
Fine. We'll actually make the X scale 1.25 too.
Ooh, snazzy.
Alright, and I think it's not quite back walled. Bam. Alright, there we go. Now it's all perfect.
Yep.
Yay. And we're going to create a new cube, which actually I'm going to just duplicate this one, which I just duplicated the one I just created, which didn't help us at all. So the plunger back, we're going to duplicate this, move it forward. Can actually make it 1.25 in the Z as well. 2.25, and we're going to get rid of the mesh filter, get rid of the mesh renderer, and we're going to make this a trigger. And you probably know where I'm headed with this. There we go. One of those values will be it. So this one is going to be called the plunger trigger. And so we're going to create a new script called shoot ball.
Oh, okay.
And alright, so shoot ball. And let's just start typing some stuff.
Let's do it. Words.
So we're gonna need a force. We're calling this one shoot ball, so it's not as a generic name. So I feel like I can cheat a little bit. So we're gonna assume that it just shoots it forward. We're not gonna apply. We're not gonna have a option for that. We're gonna do public float force, and that really may be it.
I think so.
We're gonna equal 100.
Which we can always change later.
Yep. Gives us a good starting point, though. Probably will do something, even if it doesn't do enough. So, what we're going to do is we're going to check to see if the ball is in that trigger area before we launch it. Maybe it's not best to do a trigger for this. Yeah, let's so our triggers we can do on trigger enter, and we could set that there's a ball in there and what the ball is. Let's do that. Let's go ahead and have fun with this. So this thing will launch anything that can get into it that's a physics object. So we're going to create a we're going to do using system.collections.generic, and we're going to create a private list of type rigid body what are we going to call this? We're going to call this I'm going to call it ball list.
All right.
Private list, rigid body, ball list, equals new list, rigid body with these at the end. Those thingies. And so in the void on trigger enter collider call, we're going to add things to this list. So we're just going to say if col.rigidBody, which means does it have a rigid body?
Yep.
If it has one, then we add it to the list. So we do ball list.add call.rigidBody. And then we're going to need a similar call on the exit, on trigger exit. If call.rigidBody, I think we can remove by value. So ball list.remove. Yep. Call.rigidBody. And then finally, in our update here, let's do public string button name equals fire1. We're probably going to change that, but just so that we have a default. If input.get button down this time, because we want this to be an instantaneous type thing. If get button down button name, then we apply force. So for each rigid body, body in ball list. Actually, let's call it ball.
Okay.
Ball dot add force. Vector 3 dot forward times force.
All right.
So let's see if we got this right on the first try. So we're going to go ahead and take this ball and drop it in here. And if I hit control, nothing happens, nothing happens, nothing happens. And if the ball's in there, well,
It did move.
let's bring the camera back just a little bit here. Let me just align. So let's get back into editor mode. I'm going to click on the main camera. I'm going to choose game object align view to selected. So this is what the camera's seeing. And then I'm just going to move back a little bit so that we can see the bottom of the table. And we're going to again go up here, except we're going to say align with view. So now the camera's pulled back.
Yay.
Not perfect, but it's good enough.
Works.
So it's down there, and if it's in there and we hit control, it did look like it tried to apply some. Oh, it doesn't even have a script on it, so I'm a liar.
Oh, that would be no problem.
So plunger trigger, we want to put shoot ball on here. Let's try it again. So this time I think I can get it, like as soon as it gets in there, I can just be like, bam. Okay, yeah, you saw some extra force go up there. Maybe. Not a whole lot of force.
Very small amount of force.
All right, let's try.
Bump it up to 5,000.
Let's. Yeah, sure, 5,000. Why not? So we usually fix things in the show, right? I don't think it's working.
I don't think it is either. 5,000 would do something.
You'd think. So, first of all, our ball, of course our ball has a rigid body. Our plunger trigger doesn't need a rigid body. It's
Should
set
not.
as a trigger. Alright, so let's put some prints here. So debug.log object entered. Object has rigid body. Exited.
So every time now when it enters or exits, it should shoot out a message.
Yep.
Theoretically.
So let's see what happens when we hit the console here.
So right when it hits there, it should be.
Okay.
It entered.
Object has a rigid body, so that's working.
The fire one isn't working.
Did I do transform.forward? No, I did vector 3.forward. That's the right one.
I don't know.
Debug.log applying force.
That way we
So
can
this one
actually
shouldn't
see.
print if there's nothing in there, but we'll see if it actually prints when there is something in there. Applying force. All right, let's change the way it works a little bit. Let's make it so that it applies the force as a different force mode. Let's do velocity change. This will result in a much stronger force response because it will basically ignore the weight of the ball and just, at least it should. Oh, now it's not working at all.
That's no good.
Oh,
Holy.
I didn't have it selected. That was the problem.
You didn't have what selected?
I didn't have the mouse control on the...
Oh.
It was eating my inputs in some cases, so that's part of the problem. That did fix our little problem there, so let's go to plunger trigger and change the... so that's at force 100 now.
Mm-hmm.
Let's do just force 10, I guess. So this will basically bring the ball to 10 meters per second forward. Well, 100 was better.
100 was better. Yeah.
250. And so that we don't have to wait for this ball the whole time, I'm going to grab the head of this thing a little bit. That's about right. That's about right.
Yeah, that looks good.
So now, to
just
finish it up today, I'm just going to create a little bit of a curve.
I just put it like a flat angle.
Yeah, that's what I was planning on doing.
Oh, okay.
Just, when I say a little bit of a curve, I wasn't planning on being very, very fancy. So, so what are we doing? We're just going to create a
good old cube.
Good old cube.
Can't go wrong with a good old cube.
And we'll just free rotate it a little bit. And we'll make it a little bit longer in the X. And when I said free rotate, I totally lied.
You meant 45 degrees.
Yeah, I meant 45 degrees. And we're going to move it.
Sounds like my version of free rotate.
Yeah. And we're going to make it a little bit longer again. Let's make it, I don't know, 5. Let's make a little bit of a curve.
Ooh.
I know, it's just so out of place for me to
Hey, you're just being
play with this
fancy.
stuff. So we're going to do 2 of them. We're going to do one that's like this, and we want it to kind of sink into the wall. We're not going to be perfect here. If we choose global, we can get this nice to the area here, and then let's do another one and rotate it a little bit more.
Nice.
And move it in.
I'd say that's good enough.
Yeah, that's probably good enough for our purposes right there.
Alright.
Although I want it to be at
Oh.
the same...
And when I saw him low, that kind of bummed me out. I'm not gonna lie.
Well, we fixed it. We fixed it. Thought we fixed it. Oh, where did that extra angle come from? What did I do?
I don't know.
0, 0. Somewhere in there I introduced some little bit weirdness. Alright, so let's go ahead and see how this does. And we have the ball in play.
When it's dinging around.
And
Like,
it's dinging around. Oh, and it's out of the play field, but that's really cool.
Yeah.
I actually like that. Oh no. No, 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 no. There's nothing I can do. Tilt! Tilt!
Yeah, you can't bump that table right now.
No. Nope, we can't. Alright, so,
There you have it.
there you have it. Let's do one more quickie deal we can do. So, I'm just going to use a plane, though you could get away with this with any mesh collider that you've created geometry for. Like if you create a quad, which you should do, everyone should have a quad at this point.
Yeah.
They're prefabs. I should have a quad with every episode. I kick myself for not just having a little quad pack. I'm gonna have to just make a little package or something at the Unity asset store, just make it free and just have all of the stuff that should have been in Unity from the start. But let's just for now pretend that this is a quad, and we're gonna create a plane here. And we're gonna make it 0.1 size, so that it is actually the size that we'd expect a quad to be. Now, the fun thing about planes is they default to having a mesh collider. They really don't need a mesh collider. Most of the games I work on, I actually change them just to cube colliders and just make them very thin.
Yeah.
But The default settings allow for a mesh collider, and there is one advantage to that. The mesh collider is just as one-sided as this plane is. If we go to the other side of this plane, we can't see it. And same thing with the mesh collider, it will actually operate as a one-way. And so we can put this on the to do the simulation of a mechanical ball lock system, which normally would be like a little metal flap that basically comes up when the ball goes through and then doesn't allow the ball to come back through. We can just do that with a plane here. So we're going to do that. Just going to position it 0.5. We're going to rotate it so that it's facing outwards. I'll just use this because I can't remember which one we want to go on.
And now you know.
And now I know. And then move this to the outside. We're going to make the scale on the Y, on the X a little bit.
Not that big.
Much. Something like that. Now we're going to move it forward. And we're going to rotate it 45 degrees. The other 45 degrees. That's just about perfect, honestly, but we can just do that. So now if, just to test this, I'm going to create another ball. Where's our ball? I'm just going to duplicate it and bring it up here. So you can see how this works. And if we hit play, you'll see that that ball will actually bounce and roll off, but this ball will go right through.
Oh, nice.
And so I've created a little one-way valve type thing. Obviously, we still have a lot of work to do on the play field here. We need to actually make some cool stuff. I'm going to try and figure out a system for doing ramps. Might have to open a 3D program next episode, so my apologies if I open up a program that you guys don't like or don't have.
Blender.
Yeah. Oh man, I do not like Blender.
I've used Blender.
When? Like what version?
I don't know.
You see, that's the trick.
I don't know.
That's
it was
the trick
recent
question.
enough.
Anyway, I'm going to call this a night. I think we did a lot better this time than we did on the previous episode. So that's good. Doesn't look a whole lot different, but at least you guys got some more theories, and you have a lot more places to look for tweak values. Like the thing is, there's just a lot of things that you can play with, and you're going to basically have to learn some things on this. So I'm going to go ahead and just hit save, and we're just going to do our standard wrap up. Thank you for watching. If you have any questions, email me at pushypixels@pushypixels.com, or you can tweet me at Drakfire.
If you want to email me, you can. It's philip@protosoftworks.com. You should also follow me on Twitter. That's @magmalemur. And you should buy Proton Pulse. Proton Pulse. It's you can get a free version. There's also another version without ads that you should totally buy. You could get it on your iOS device and on your computer.
Yes, on your Macintosh computer, and actually you can get a PC version now too, although that link's kind of hard to find now, so I need to work on my website. You should also buy Automation, and that is available on the iOS App Store, and it's a great little game, and your free week is done, right?
It's over.
How'd that go for you?
Went pretty well.
Awesome. So few more players on the game, and that's great. That's great.
I agree.
Anyway, thank you for joining us, and you have a wonderful week.
Have a good night.